In 1977, we did something extraordinary. We let go. Two machines left Earth and just kept going, past the giant planets, past everything familiar, deeper into a darkness no one had ever truly seen. They sent back images that shook our understanding of the solar system to its core, and what they revealed wasn't just scientific data, it was wonder. Voyager 1 and Voyager 2 weren't just probes. They were humanity's eyes drifting outward, showing us storms the size of continents, moons that breathed fire, rings of breathtaking complexity, and a version of home so small it barely existed. But here's the thing that makes this story different from any other space mission. The Voyagers didn't just discover new worlds, they changed what those worlds meant. It all started with a once-in-a-lifetime opportunity. In the late 1970s, Jupiter, Saturn, Uranus, and Neptune aligned in a configuration that only repeats roughly every 176 years. If a spacecraft launched at just the right time, it could use each planet's gravity as a slingshot, a cosmic relay race through the outer solar system. NASA recognized the window and moved fast. Voyager 2 launched first on August 20, 1977. Voyager 1 followed 2 weeks later on a faster trajectory, destined to overtake its twin. Together, they weren't just sent on a mission, they were sent as pioneers into territory no machine or living thing had ever explored up close. And days after launch, Voyager 1 turned around and photographed Earth and the Moon from millions of kilometers away. That quiet early image felt like a farewell, but the real surprises hadn't even begun. When Voyager 1 reached Jupiter in March 1979, the solar system cracked open. Jupiter had been observed for centuries through telescopes, a banded sphere, distant and somewhat predictable. Up close, it was something else entirely. Towering atmospheric columns, churning plumes, clashing pressure systems, and storms folded inside other storms. The Great Red Spot, long theorized as a storm, was confirmed as a colossal rotating engine with no intention of stopping. Jupiter felt less like a planet and more like something alive and angry. But Jupiter itself wasn't even the biggest shock waiting there. That honor went to Io, one of Jupiter's moons. Before Voyager, scientists expected it to look something like our own moon, ancient, cratered, and silent. What the probe found instead stopped researchers cold. Active volcanoes, real eruptions blasting material hundreds of kilometers into space. Lava lakes, a surface so geologically violent it had to be constantly rewriting itself. It was the first time active volcanism had ever been confirmed on another world. Nobody had predicted it. Nobody was ready for it. And right next door, Europa told a quieter but equally stunning story. Its icy surface was covered in strange fractures, long crisscrossing lines that hinted at movement beneath. Liquid water, possibly, hiding under a frozen shell. In a single planetary system, Voyager had found a world on fire and a world that might harbor an ocean. The outer solar system had just stopped looking dead. Then came Saturn. And if Jupiter was a revelation, Saturn was a riddle wrapped in impossible beauty. From Earth, Saturn had always seemed elegant, serene, the planet of rings and symmetry. But Voyager tore that image apart. The rings weren't a few broad, smooth bands. They were hundreds of individual ringlets, kinks, gaps, braided structures, and ghostly spoke-like patterns that defied easy explanation. New rings were discovered. Shepherd moons were found holding narrow bands in precise formation. Saturn went from the most graceful object in the sky to one of the most mysterious in a matter of photographs. Saturn's moons added more fuel to the fire. Titan revealed a thick, nitrogen-rich atmosphere, the only moon in the solar system known to have one, and it instantly became one of the most compelling objects anyone had ever pointed a camera at. Enceladus showed early signs of internal activity. And just like that, Saturn transformed from a beautiful backdrop into a system full of worlds demanding answers. But one probe was about to leave all of this behind and head somewhere even stranger. After Saturn, Voyager 1 was flung upward out of the solar system's plane and set off toward interstellar space. Voyager 2 continued the grand tour alone, and in 1986, it reached Uranus. At first glance, Uranus looked almost boring, a smooth, featureless atmosphere with none of the visible drama of Jupiter or Saturn. But appearances were deeply misleading. Uranus was tilted almost completely onto its side, its rotational axis tipped over as if something massive had knocked it down long ago. Its magnetic field was wildly misaligned, wobbling in ways that forced scientists to reconsider how planetary magnetism works. New rings and new moons were found, including Miranda, a moon that looked like it had been shattered into pieces and reassembled incorrectly, covered in canyons and cliffs that had no business existing on something so small. What could have done that? Nobody knows. Then came Neptune in 1989, the last stop of the Grand Tour, and it refused to go quietly. At the edge of the known solar system, Voyager 2 found not frozen silence, but fury. Neptune's winds were some of the most violent ever recorded in the solar system, ripping through its atmosphere at staggering speeds. A massive storm system called the Great Dark Spot churned across its blue surface. Its rings were fragmented and dusty, forming strange arcs that raised new questions about how ring systems form and survive. And Triton, Neptune's largest moon, delivered the final punch, a frozen, fractured world sending dark, geyser-like plumes upward from its surface in one of the coldest places ever visited. By the time Voyager 2 left Neptune behind, the message was impossible to ignore. The outer solar system was not a quiet, frozen museum. It was restless, dynamic, full of worlds that had been hiding extraordinary secrets behind the veil of distance. One of the deepest shifts Voyager triggered was in how we think about moons. Before the mission, most moons were treated almost as furniture, small companions orbiting the big planets, interesting perhaps, but not the main event. Voyager demolished that idea completely. Io erupted. Europa hinted at hidden oceans. Titan disappeared behind a chemical atmosphere thick with possibility. Miranda looked broken and rebuilt. Triton breathed cold plumes into space. These weren't decorations, they were worlds, each one carrying a history large enough to justify its own dedicated mission. And that changed something deep in how we map the solar system emotionally. It stopped being a handful of planets with silent escorts. It became systems within systems, entire families of worlds, each one stranger than the last. But nothing Voyager showed us compared to what happened when one of the probes turned its camera backward toward home. Far from the planets, deep in the outer dark, the image it captured was almost unbearable in its simplicity. A tiny point of pale light, barely visible, suspended in a beam of scattered sunlight. Earth. Every war ever fought, every monument ever built, every life ever lived, all of it contained in something too small to easily see. That image became known as the pale blue dot. And in a single frame, the mission stopped being purely about discovery. It became about perspective. The Voyagers had crossed the domain of giants, and then quietly reminded us that we live on a speck. Most missions are defined by where they stop. Voyager is defined by the fact that it never did. After the planetary encounters were over, both probes continued outward into a region no spacecraft had ever entered. The solar wind grew thin. The familiar influence of the sun began to fade. The environment became stranger, quieter, as if the probes were approaching some invisible threshold at the edge of everything we call home. And then they crossed. Voyager 1 became the first human-made object to enter interstellar space. Voyager 2 followed years later. Two machines built in the 1970s, still alive, still transmitting, still speaking to us from beyond the boundary of our solar system. That is not a metaphor. That is a fact. There is one final detail that gives this mission its haunting emotional weight. Each Voyager carried a golden record, a message not addressed to scientists but to the unknown. Sounds from Earth, ocean waves, wind, rain, music from dozens of cultures, human voices speaking greetings in many languages, photographs of life. It wasn't sent because anyone believed it would definitely be found. It was sent because the act of sending it said something true about us, that even as we mapped our own smallness, we reached outward anyway. Voyager was built as a scientific probe, but it became something harder to define. A time capsule. A messenger. A portrait of a civilization standing at the edge of its own solar system, looking outward for the first time, and choosing, deliberately, to introduce itself. Before Voyager, the outer planets were blurry ideas. After Voyager, they were places. Jupiter became a realm of endless violence and volcanic moons. Saturn became a labyrinth of impossible rings. Uranus became a tilted mystery with a broken magnetic field. Neptune became a blue giant of ferocious winds. And Triton became one of the strangest frozen worlds ever touched by human curiosity. The solar system went from familiar to astonishing because Voyager proved that distance had been hiding detail, not emptiness. And the most powerful thing it revealed wasn't any planet or moon. It was us, reflected in a pale blue dot suspended in the dark, fragile and remarkable, on a world small enough to disappear, yet somehow capable of building something that crossed the stars and kept speaking. The probes are still out there, still moving, still transmitting faint signals across impossible distance. And somewhere in the dark between solar systems, they carry a golden record with our voices on it. Proof that once, from one small world, a civilization looked up, built 2 machines, and sent them into the unknown just to see what was there. That may be the most human thing we have ever done,